Hi, welcome to lesson 1, video 7. In this video, we're going to be talking about scenarios in Leap. In this video, we will have the main method for doing scenarios. There are two main methods. One of them is more complicated than the other, but also has some practical benefits. We're going to talk about the scenario window where you set up scenarios. We're going to talk about scenario inheritance, which is one of the most important principles in Leap, which is also a very big helpful function in Leap. And we're going to talk about the main modular and aggregated scenarios, which is the other way of doing scenarios, which is not as much used, but it can actually come with some really big benefits if your design or if your task permits it. So, generally speaking, here's the Leap window, and we are going to do scenarios in Leap. The scenarios window is in the scenario. Sorry, we're going to design a scenario in the scenarios window, which we will find here on top of the Leap main window. It is only available in analysis view, if I'm not wrong. If you open the analysis window, we can see this. In this case, I'm taking it from the Freedonia model, so you can follow along with me. So here we have, you can see, you have an overview of different scenarios over here. We always start with the current accounts. I have been referencing this scenario for a bit, and now I will explain a little bit further. And in this case, there is a reference scenario and a number of other scenarios, as you can see, and they're all stacked inwards. So this has something to do with inheritance. So all of these scenarios here, they inherit from the one that's further in, which is the reference, which again inherits from the current accounts. So that is the basis of scenario inheritance. But first, about current accounts. When you are in the analysis view, you can open up your scenario. I can show you that in a second. Scenario is chosen, and that is where you put in your function. You will always have the current accounts. That is your statistical scenario. All other scenarios have to depend on that. Here I'm just calling it a CA scenario to not avoid confusion. So in the CA current account scenario, you can see that starts in the base year, as we said when we were talking about the setup of a given model, and it ends in the year before the first calculation year, usually the year that you're in, or your last statistics year. So that is when you have your current accounts. All other scenario, no matter how you look at, they are in the projection year. So those are projection scenarios. And that is what defines the current accounts. The current accounts also is the accounts where you have to specify profiles. In stock turnover analysis, there we will get into that. And also units are specified in current accounts. So if you cannot change the unit of one of your inputs, check which scenario you have to be in current accounts. Now, again, here in the settings window, you can see we have the base year and first scenario. And again, those are where current accounts are. And then end year, all the scenarios are in there in between where you have prediction scenarios. Just to reiterate. So what does that mean in practicality? Well, when you're inheriting scenarios, you are specifying it in the topmost scenario left. So in this case that we have here, we of course have our current account scenario. That's where our statistics lives. Then we have a number of main scenario. In this case, we have a business as usual scenario. We call it BAU. And in here we have in a big industrial sector. This is some Behasa scenarios, real examples. And here we have one where we have a lot more liquid petroleum gas in our model. And those are our three main scenarios. Then, inheriting from the BAU, we have a sustainable development scenario, and a deep decarbonation scenario. So these are scenarios that refer back to the BAU scenario. What that means in practice is that everything is the same in these two scenarios as they are in the BAU scenario, except where we specifically make changes. The same goes for the next level. I have to clean this up a little bit. So here you can see we have some transport related scenarios, which are transport study moderate and transport bio. There we have changed something related only to transport, but we did that on the basis of the sustainable development scenario. And that means in those two scenarios, everything is the same as sustainable development, except for explicit changes in transport study moderate and further on transport bio, which again refers back to transport study moderate. And we have the same thing here where we have the transport study deep carb, which refers back to the deep decarbonization scenario, deep decarbonization scenario. So, and how do we recognize explicit changes? Well, those are functions that are listed in blue color. So if you've seen those in the former videos, that's why they're blue. That's because those are specific to the inherited scenario that we are in. So the practical application for this is that most models, other than current accounts, usually have some kind of BAU or reference scenario. So here we have two other weird scenarios that we don't really use in this case. Those have been defined differently. But here we have one major reference scenario, and here it is BAU. So every other scenario inherits from that scenario, because then we have those projections to 2050, and those are the ones that we think is our baseline, except where we are diverging specifically from this. And we do that in blue in the different scenarios. So here we have a small example of that. Here we can see we can look at where we are in our branches. It's listed all branches. We are now in activity level. That's what we can see here. That's the same we have here. We can choose that. But more importantly, here we are in the efficient lighting scenario in Freedonia. So insisting in whatever I am, in this case, households, urban, electrified, lighting, existing, efficient, yada, yada, yada. That's where I am in my branches. All of these things here that are listed in blue comes from a different scenario. In this case, our baseline scenario, except my new share of efficient lighting, which is what I've done in my efficient lighting scenario. So that's specifically what I've done. So this blue change is specific to this efficient lighting scenario. And that's how you recognize that. That is the way you navigate through the model. You look, okay, so this is inherited, this is specific. Okay, that's what we look at. Then I want to take that a little bit back and talk about aggregated scenarios. So that's the simple way of doing a scenario. That's what I just showed. But we have one reference scenario that then inherits to other scenario where we couple on more and more changes that are specific. Those are good for bigger main scenarios, but we can do aggregated scenarios, which is quite interesting as well. So in traditional scenarios, which I showed you before, we have a number of changes, just giving colored boxes, which are in this one we have a stated policy scenario, which is more or less a slightly differently specified BAU scenario, or baseline scenario. And here we have some changes. And here in a high RE scenario, we have different changes, different data. So that's how we specified those. Now, if you have these aggregated or cluster scenarios that don't really have a good name, what I can tell, we are doing something differently. So here we are still specifying some kind of a reference scenario, just like before, same things, put that in. and then we specify the same number of changes, or same specific changes. But instead of doing that, we actually make a scenario for each of these changes, which could be a specific policies. And these specific changes can be one functions or multiple different functions in multiple different branches. You can do almost whatever you like with a few limitations. And then we just apply that differently places. So we say, in our standard scenarios, that's where we have this specified our standards. But in the one that we call aggregated scenario, we call medium, and we have another one which are high RE. So in this case, we take this particular policy change and apply it to high RE. We take this particular policy changes and apply it to both medium and high RE. Maybe this is a change we don't want to mess with, so we put that under the high RE. We can do different things as long as it's differently alternative to each other. In this case, I'm showcasing that the high RE scenario is specified by having keeping this specific change, while the medium has a different specific change on the same function maybe in the medium. But instead we have a change on the blue alternative to the baseline blue that is still in the medium and in the reference. It sounds a little complicated, but what it's really useful for policy scenarios. So here I have set up a below 2 degree scenario. So this is a main scenario, and here I'll split it into my main branches. So I'm saying that I have industry, agriculture, construction, building, and transport. Those are my main branches. But what I can still have, instead of having a big below 2 degree scenario, is I can pick and choose. So I made a small scenario for steel electrification, one for chemistry fuel switch, one for cement fuel switch, one for ferrous metal fuel switch, and so on. I haven't done anything with agriculture and construction in this case, but here I have my building scenarios. I have my commercial buildings, which will use some different heating. I have some residential cooling method that will be more effective maybe. I have some transport non-road that will be used more electrified. I have some road passenger cars, vehicles that are more in line with electrification and direct RE maybe. So I'm making a lot of these, and each of these is like a small single policy scenario, I would call this here. So it's a one minor change to my general model saved as its own scenario. So in the scenarios window, the traditional one will look like this. We have our current account has to be there, that's statistics. And then we have our baseline, in this case frozen policy. And then we have two scenarios which are on the same level, so they don't really interact with each other, but they're both based on the frozen policy with some specific changes that makes them their own scenarios. Now, on the other hand, here we have a massive number of scenarios, and actually all of these are single policy scenarios. What these do is here, for instance, let's take the iManuf, I called one of them, or aggregate one of them, that is a high RE and electrification in manufacturing sector. So there we put more electrification in the manufacturing sector specifically, did nothing else saved as a scenario. And you can see they are perfectly in line with everything else, every other scenario other than reference stated policy, which is our reference policy, and current accounts again. So here, every scenario is the same as the reference scenario, except for a specific change. Now, if you notice, some of these have a little bit of a parenthesis on it. Here. So here I took, these are all the ones in red. Those are all my single policy scenarios that are related to my industries. So here in my industry aggregated scenario, I have then collected all the different changes in all of these marked in red scenarios and just put them into one. So I can say, sure, I want to have single policy scenarios, but I also want a scenario where I change a lot of things in industry. So that's my industry Creo 16, in this case, aggregated scenario. I have a similar one for transport, which is a lot of different single policy scenarios for transport, but they all come back to this all come back to this aggregated transport scenario. Now, what I then also done, did the same thing with buildings. What I also done is I have taken all of these ones, the aggregated scenarios, included something with a construction and agriculture that isn't aggregated, and then I can put that into another aggregated scenario. So this DVH2, I forgot what it's actually called, but it's a below 2 degree scenarios with inherent aggregated scenarios. These are actually combined of all of these scenarios, which again are combined of all the other scenarios in different ways. So I do have a big mainline scenario, which is my DVH scenario, but I build them of smaller building blocks. And that's really, really smart if you want to do very specific changes in one sector or multiple sectors. So I can say we're going to now have a policy of having more insulation in housing. So I can put in better energy efficiency of all my different housing sectors, save that as a specific scenario that will just touch that and nothing else, and then combine that with another scenario that says now we're going to heat with heat pumps which has a higher energy efficiency and is electric on specifically our heating, but not an insulation, and then combine it with a different scenario that says now we're going to do natural gas cooking instead of having electric cooking maybe, and combine those into a specific scenario, a combined aggregated scenario that then we can call something else and then calculate that. Downside of this, longer calculation time because you have to calculate all of these. Especially if you're doing this, and especially if you have regions, you have to have a 64-bit Leap software, because then you can use more of your RAM in your computer, which is a weird technical limitation, but that's generally how it is with software. This is where it becomes important. The same principle with aggregated scenarios, but in a smaller and a more manageable model. This is a Freedonia model, so you can also go and look at that in your Leap software. So here we can see we have an aggregated scenario that is displayed with a parentheses A. But the question is, what other scenarios is it using? Well, if you go up here in the show additional scenarios in 3 parentheses A and click this little box, you can then see quite quickly that here it will then come up and tell you which scenario it's come from. So you can see here it's the light F, CNG, NAT, and INT scenario. Now they're ticked it on, and in this case it's actually all of the underlying scenarios that it's using. But those can be ticked on and off, which I will show later. Now, with inheriting scenarios, which is the basic one, again, everything is as the parent scenario except for the specific changes. That's what we had before. The aggregated scenarios, then everything is at the same as the parent scenario except for specific changes, just like before. And then also specific changes from additional scenarios. So if you have a scenario like the DVH2, which we see right here, then everything by the basis is the same as the reference scenario that it inherits from, which is the parent scenario to this, and also all the specific scenario that is coming from below, and again, which is comprising of quite a lot of different scenarios. So it is actually two things. So this can also have independent from any other scenario changes. So you can specify both changes in the scenario itself and scenarios coming or changes coming from the other scenarios. That can be a little bit confusing. So if you make an aggregated scenario, I would actually recommend not doing anything other than taking scenarios, single policy scenarios in. But again, you could also make a normal scenario, main scenario, with just a single policy scenario you could tack on and off depending on your needs. So how do you take scenarios on and off? So if you go in and choose a scenario, so in this case I chose the industry aggregated scenarios. We can see that by the little A. We haven't tick the box on to show all of them. But if you then go into the inheritance over here, which is usually empty, but in this case, because it's an aggregated, you can see it lists all the scenarios we have. We actually inherit from not the reference scenario, because that's a different form of inheritance, but these are just the additional scenario. So you can see it's based on stated policies, which is our reference scenario. So that's listed up here. We could actually change that, but that would change also the physical location of our scenario in our scenario branches. And then in the additional scenarios, we can see where it also takes data from. If we have click one of these, and then we have the minus will light up, and we can remove it at will. The same thing if we press the plus, we could choose even more scenarios we want. We can put into this, which is at the same level or lower than our, in this case, industry scenario. And that's how you can take them on and off, which also means you can make them, you can have a single policy scenarios where you don't delete the scenarios and you don't delete the data that you actually made, but having them in a single policy scenario means that you can remove it and add it quite quickly if you want to. So again, to reiterate, both in terms of benefits and costs, the inherited way, that's mentally quite natural way of doing it. You have a baseline scenario, you make a new scenario that has a few changes, that's a new main scenario, make another scenario next to that has different changes, probably in the same places, and that's a different scenario. And that means you have one reference scenario that defines your system, like how does things develop in general, and then every other scenario just define all the changes, deviations to that system itself. And then you have multiple alternatives or policies, what you want to call them, in a certain scenario. So you have an alternative, you have a number, hundreds maybe even, alternative developments towards your baseline. That's what is in the inherited scenario. For aggregate scenario, you can choose to make single policy scenario. You can also have a scenario that has multiple policies, but I think the strength is just defining one. So now we have a policy where we want to have more EVs on the road. Now we have a policy where we want to have more rooftop solar heating systems. Now we want one where we have more efficient coolers or more efficient refrigerators. We have another policy where we have more insulation or shadowing on windows, all of these things. And then we can do that. We can have an aggregate scenario, which is a package of these single policy scenarios. And that means we can have basically a policy package we can then calculate, which is very useful. So that means we can also check things on and off. What if something became too expensive? We can maybe remove a scenario instead of having to redefine somewhere in our model. It's like, okay, so maybe we won't do more efficiency cooling because it might not be as important when we have more insulation and shadowing, which are maybe cheaper in our case. Let's take one off and see, okay, the cost was a lot less, but the actual energy consumption was not a big difference from having it on. That's good. We can work with that, then move forward. The problem with this is like all of these single policy scenario is a full scenario, because again, if you have linking, if you have other different things, you have maybe your single policy in some specific part of your model might influence all other parts, so they all have to be calculated as a full scenario. So you have to calculate all these. So if you, like my example, we had 16 single policy scenarios, that is 16 more scenarios you have to calculate before you come to your main ones. That is a bit of a problem computational wise, maybe. It also makes quite a lot bigger model in terms of when you have it with calculations. Also, if you have two single policy scenarios at the same level that changes in specific places, like in the same place, then you can break your calculation and it will warn you. Then that means if I have a policy of getting more people to take public transport instead of going in cars, and I at the same time have a policy of having more people take their bicycles instead of their cars, well, they both will try to reduce the number of cars. That could, if they mix that into an aggregated policy, that could break, and the model will tell me that, and I won't successfully be able to make an aggregate scenario. So that's some of the problems you can have. Generally speaking, that's also why I defined an industry transport as one, was to try to avoid some of these problems.